guys would go ahead and do problem number 3. And this is on energy calculations involving phase change, practice number 2. So you guys, we did a practice worksheet yesterday. This is that next page in your packet. It's just practice number 2. Okay? So we'd like you guys to work on problem number 3. Okie dokie. So we're working on problem 3 right here.
There's 5 cubes.
There might be. Who can say? Who can say? So, go ahead and work on this. I'll come around to check in on folks. And
There's 3.
then we'll get cooking. So let's talk about number 3 here. So what I love to do is I love to get my graph here. So going up, flat, up, flat, up. So remember that shape. And then all I need to do is remember the 2 numbers. Okay, so this first flat part happens at about 0 degrees Celsius for water, and the second flat part happens at about 100. Now if I can remember that, I'll be in pretty good shape. Okay? I saw a lot of people using this graph on the right. I strongly encourage that. So, it says calculate the heat needed to change 475 grams of water at 40 degrees to steam at 120 degrees. So, where am I starting on this graph? Well, it says 40 degrees. Okay, so I don't know exactly where on this line that would be, but I know it would be on this line somewhere. It doesn't really matter where I put that red dot. I just want to make sure I'm in the right section. Okay? And then it goes to 120. That would be above the 100 line, so maybe here. So if I'm looking at this, how many Qs do I have to calculate? I have to calculate 1, 2, 3 Qs. Okay, so there are 3 total Qs I need to calculate. The moment I realize that, okay, because this graph is really just about planing well, I'm going to go ahead and write Q1, Q2, Q3. So this is a 5Q question, but there's only 3 Qs that we need to calculate. Remember, 5 is the maximum number of Qs that you might have to calculate. Okay, so let's see if we can get each one of these written out. Let me see here. Mooney, for this first section, is there an increase in temperature? There is. Okay, so we're going to use which equation? Q equals what? Absolutely. Okay, so what's my M? What is my mass here? Love it. What is the C for this particular section?
4.18.
And how did you know to use 4.18 instead of like 2.06 or 2.02? Because it's a liquid. Love it. Okay. Love that. Love that. By the way, this chart up here at the top, this guy up here, that's exactly the picture that you'll be given on your quiz. So if you're comfortable with this, you're comfortable with what's on the quiz. And Minnie, how much is the temperature changing in this particular section? What was that?
40.
40. We're close, very close. So we're going from 40 up to 100. So what's the difference there, going from 40 to 100? It'll be 60, yep. Now, if we were going the other way, if we're going 40 down to the 0, that would be a difference of 40. But do you see why that's 60? Okay. Can someone tell me what these 3 numbers multiplied together comes out to be?
119,130.
That was what you got right there?
Yep.
Okay. All right, for this next section, let's see here. Bree, is there a change in temperature for that next section? Can we use Q equals MC delta T? No, we can't because there's no temperature change. So what are we going to use? Q equals what? Yep, M delta H. So what's our mass? What's our delta H?
2,460.
Yep, this is the expensive bridge. This is the expensive bridge, so we need to use that expensive price. That's all we need. So what do those 2 numbers come out to be?
2,073,500.
So 1073. Uh-oh. Don't want that. 1073500. Is that what you got? Okay, nice. All right, and then lastly, let's see here. Mr. Williams, in this final section right here, is there a temperature change?
Yeah.
So we're going to use Q equals MC delta T. What's my M?
475.
I hope you guys are getting annoyed with me asking what the M is every time. It should be the same. What is my C?
2.02.
Love the 2.02. It's a gas now, so we're using this guy instead of the familiar 4.18. And what's my change in temperature?
20.
It's just 20. Now I know that going from 40 to 120 is a total change in temperature of 80, but we already paid for 60 of it in that first cube, okay? And so we just have the remaining 20 to go. Adam, what does that come out to be?
19,190.
All right. So those are our 3 Qs. I'm going to go ahead and erase my little graph just because I need the space. What do those add up to be total?
1,111,820.
That's it? Units?
Joules per gram.
Oh, degrees Celsius? That's actually the heat capacity unit, because remember, heat capacity is a ratio of joules to grams. This one's unit should just be joules. Remember, this is a heat energy, so it's just the total in joules. All right, put a box around that. Okay. Now, here's what we're going to do. There we go, okay. So here's what we're going to do. I'm going to show you what the practice quiz looks like. Okay, so if you're virtual folks, you probably want to pull up the practice quiz. If you live folks, you'll probably be okay just watching me here. All right, so this question right here is the exact same question on the practice quiz on Schoology. So if I go ahead and shrink that a little bit, I come over here. So in the Tuesday folder, there's the official quiz and there's a practice quiz. See how this says practice, not worth points, okay? So there's only 4 questions in this practice quiz, and they're the first 4 questions on this worksheet. So if I go ahead and scroll down, I go to number 3. Let's see here. So that's the problem we just did. It's talking about 475 grams of water, 40 degrees Celsius, 120. So here's what we need to do. There are 17 boxes on every question, because that's the maximum number that you might need. You need to fill in all 17, no matter how many Qs you calculated. I'll show you exactly how to do it. So you can't leave any of these blank. So on that problem we just did, okay, our first calculation, we did the 475. We had a 4.18. We went up by 60 degrees. So we plugged that in, that's good. Then we had the 475. Again, you can I can follow along my work right here. Then I had the 2260, so I plot that in next. Then I had, there's nothing next, okay? So here's what you need to do. I can't leave this blank. This is very important. I can't leave this blank. I need to grab the box that says not needed and drop it in there. So I only use 2 things to multiply together, and for my Q2, not 3. So that third box, I can't leave it blank. I need to put in not needed. And then looks like I got 475 again. Plop. 2.02. Plop. And finally the 20. Okay. Now the rest of these boxes, I didn't calculate a Q4, I didn't calculate a Q5, so I need to drop in not needed for all those. So if you have anything less than 5 Qs, you'll have entire rows that are not needed. Then it says Q total. I find my number, I got 1211820. Oh, there it is right there. The units are joules. There you go. And that's how you can get a full credit answer if this was your actual quiz question. Does that kind of make sense? Okie dokie. So that's how we're filling these out. I just want to make sure you guys saw that formatting. The quiz questions you guys are doing today are literally copied from this quiz question, and I just changed the numbers. Okay, so this is exactly what it'll look like. It's exactly what it'll look like. 17 boxes in all. Okay, so there's that. Here's what I suggest you guys do. I suggest you guys practice for a couple more minutes, maybe do one more problem, and then I'll sort of announce that you guys should go ahead and get started on your official quiz. Does that make sense? And during this practice time, you can open up the practice quiz and make sure you understand the formatting if you want to do that, if you feel like that will make you more comfortable with your current quiz coming up, okay? So it's 12:58, at about 1:01-ish, I'll tell you guys to officially start that quiz, okay? So 2 or 3 more minutes, get some good practice in, take a look at your notes again, maybe do one more problem, whatever you want.